All right, chapter 7, section 3 is using similar right triangles. So this is going to be the one where you saw that poster up at the front of the classroom that was up there, and we're going to see a lot of it. It starts off being like, okay, this is pretty easy, and it's not hard. It's just like, wait, what was that? What's this thing? What's that thing? It's just sorting everything out at the beginning. Okay, so the first thing we're going to talk about is the geometric mean. And when we talk about the geometric mean, when we talk about the mean of something, the word mean just means the average. But a geometric mean, when you are given two numbers, when I give you two numbers, it just means take the square root of their product. So for example, if I said, give me the geometric mean of 36 and 49. What you would need to do is multiply them and take the square root of them. But I would tell you, that's a terrible way to do this. That's what this means there. It means take the square root of their product. Product meaning multiply, and the square root of that. But I'll tell you why. Like, first of all, 36 times 49 is, you're going to sit there writing it out for a while trying to figure it out. It is the square root of 1,764. How many of you off the top of your head know what the square root of 1,764 is?
42. I don't know. Oh. Is it?
This is going to be funny.
Is it?
Did you do this on a calculator?
No, I swear.
Okay, so I would never do it this way because honestly, if you just threw that in front of me, I would be like, I don't know the square root of 1,764, but watch this. I'm going to show you how, so the thing is I can do this in my head, but I'm kind of lying to you because I'm not actually doing the square root of 1,764. What I am doing is I understand that this top line here is exactly the same as this. What is the square root of 36?
6.
What's the square root of 49? What's 6 times 7? My guess, is that what you did in your head?
Yeah, that's it.
Okay, so the thing is that is a good strategy. So I say that because when I ask you to take the geometric mean of two numbers, you need to understand, and it'll ask you for this on the homework, and you should be ready for it if I ask you for it on the quiz. If I give you two numbers and I ask you for the geometric mean, it does not mean add them together and divide by 2. That is the average or the mean of something. The geometric mean takes the square root of their product. If you would like, you can either sometimes it's easier to do the square root first, and then multiply them together. But sometimes you're like, well, I don't know these two numbers. I can't. For example, like this. Let me show you an easier one. Like, let's say I said, take the geometric mean of 5 and 20. So square root of 5 times the square root of 20, would we agree that, this is going to get ugly, right?
Yeah.
Yes.
However, what if I multiplied them together? Right. If I multiplied them together first,
then you get 10.
I would get the square root of 100, which is 10. So you just have to look at the two numbers and say, if I already know the square root of the two numbers that are there, just already take the square root of them and then multiply them together. If I don't know the square root of them, well then multiply them together, like take the square root of whatever it is multiplied together. You can do it two different ways. Now we're going to use this concept to do something that is kind of two separate formulas coming up here. All right. Let's start with these. So we've got find the geometric mean of the given numbers. So again, it says like we've got 4 and 20. Let's start there. The geometric mean of 4 and 20. So I don't care which strategy you take. Actually, any strategy will take you to the right thing. Some of them are just harder than others. So what should I do with these two numbers?
So you just find the square root of 4 first, and then,
Okay.
which is 2.
So he wants to do it this way. I don't have a problem with either. I'm just going along with whatever you guys say. I'm not saying this is right or wrong. I'm just saying let's do it the way that he said. Okay, now what?
You get, for 4, you get 2.
Okay.
And then that one doesn't break down, so you have to break it down.
Okay. I like everything you're saying.
So then what I did you can do 4 or 5. And then you get 2 square root of 5.
What do I do with this? 2 times 2 times the square root of 5?
Square root of 5?
4 square root of 5. let me show you that to prove to you that if you had done it the other way, it would have worked exactly the same, okay?
Oh, I'm ready?
Yeah, you're right.
Oh, okay.
So let's say that we started off with the geometric mean of 4 and 20, just like we did before. And let's say you're like, you know what I'm going to do? I'm going to multiply them together. 4 times 20 is 80. And now I'm going to take the square root of that number. Well, we still have to break it down, don't we? Now, remember, when you break it down, give me one of the numbers that we can take the square root of. I don't care what you pick. Just give me one that we can take the square root of. I'm so glad you said it because you said it yesterday too, and I'm glad you said it again today. 16 and 5. What is the square root of 16?
4.
Notice it still ended up as the exact same answer either way. So whether you multiply them together and then take the square root, or whether you take the square root and then multiply them together, you're still going to get the same thing. But in some cases, you'll notice it right away. You're like, oh, I could do this. Like, I know the square root of those numbers right away. Notice this one. What do you think I'm going to do first? Am I going to multiply them together, or am I going to take the square root of them first? Tyler, what do you think? Right, because I know the square root of 9, that's a familiar number, and I know the square root of 25 right away. That seems easy to me. Square root of 9 is?
3.
And the square root of 25?
5.
So, final answer? 15. Beautiful. So do we feel comfortable if I give you two numbers, how do we do the geometric mean? Okay. Here's where the fun starts.
I just understood that.
Right, and I'm going to help you understand the next part. Stick with me, kid. I got you. All right. I'm going to give I realize you guys have blanks to fill in. If the altitude, remember the altitude goes from a vertex to the opposite side and it makes a right angle. So it's kind of like the height of the ceiling. It goes from floor to ceiling. If the altitude is drawn to the hypotenuse of a right triangle, this has to be in a right triangle. Notice here, this is the altitude. If I were to take a right triangle and draw an altitude in it, then those two new triangles, like notice that like there's three triangles going on here. There's the big one, ABC, right? That big green one. And now there's two new ones because I drew that altitude. There's the one on the left, which is ACD, and the one on the right that is ABD. Do we see all three triangles?
Yes.
Yeah.
If not, call me out because I would rather you be like, I'm sorry, I don't see one of them, and I could just point it out to you. Okay, we're good with where the three are? So when we draw that altitude in a right triangle, first of all, this has to be a right triangle that we started out with. That should be drawn in there. I'm sorry, add that to your notes right there that it wasn't there. This only works in a right triangle. If you do this in a right triangle and you draw the altitude in there, then all three triangles are guaranteed to be similar, meaning that they are the exact same shape, but not necessarily the same size. When we talked about similar triangles, we talked about like models of things, right? Like you've got the Statue of Liberty and you could buy a model of the Statue of Liberty. When you buy a model of the Statue of Liberty, you're not buying a full-size one. You're buying one that looks exactly like the real thing. It's just a shrunken down version. Same thing with this, is that those three triangles, the one on the left, the one on the right, and the big one, are exactly the same except for in different sizes, right? Like, you know when you buy shoes? Like you can get the same shirt, like you're a sneakerhead, right?
Yeah.
So like I don't know, are people still into Jordans? Like,
Yeah.
Okay, so like if like let's say you've got 3 pairs of Jordans, when you go and pick out a pair, you're going to ask for it in a different size, right? So you're like, I want that shoe in this size. That's what these triangles are. 3 triangles, all the exact same triangle in different sizes. One is the big one, the giant green one, ABC. There's a medium one on the right, ABD, and there's a small one on the left, ACD. They're all exactly the same. They're just different sizes of the exact same triangle. You'll have to believe me on that one for now, okay? All right. So this is your very first equation or that we need to remember, and I'm just going to draw a little box around it and star it, that this you must commit to memory. It has to be there. That's what was on the poster that is now taken down. And I'll talk to you about what it means in a minute. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. So I'm going to give everyone a second to write because what I say after this, I want everyone to like be watching while I do it. So take a moment to write in what you need to and then give me your attention after that. Okay, so here's what this says. In a right triangle, the altitude from the right angle, so we're talking about in the biggest triangle here, if I go from the right angle, here's the right angle up here, in the biggest triangle, if I go from the right angle to the hypotenuse of the other side, what it does is, notice that I just ran into the hypotenuse right here, right? This is the hypotenuse of the biggest triangle. Do you agree? it is now split it up, and not evenly necessarily. It broke it up into two parts. The first segment, and I don't care which one you call first and which one you call second, there is the first segment and there is the second segment. It's two parts of the same hypotenuse there. I didn't change the length of it. I'm just breaking it up into two sections there. Segment 1 and segment 2. I don't care which one you call segment 1 and I don't care which one you call segment 2. It's like if I said, hey guys, there's 2 pieces of pizza on the table. There's one for each of you. I don't care which one you call pizza number 1 and pizza number 2, just each of you gets one. Same with this segment. There is one segment and another segment of the hypotenuse. You gotta hear my words because I'm gonna keep saying this over and over. It is a segment of the hypotenuse. The hypotenuse is broken into two segments because I'm gonna get real wordy here in a second. You'll be like, oh yeah, he just means those segments of the hypotenuse. The length of the altitude is the geometric mean of the lengths of the two segments. And all it means is that if you want to know what the length of the altitude is, let's say I want to know how long this is right here. Like I'm interested in is what is x? If I want to know what is x, the height of that altitude, well, all I need to do is take the geometric mean of the two segments. So I'm going to take this segment, and I'm going to take the geometric mean of that. And just a minute ago, we learned all you have to do is multiply those two things together and then take the square root of them. But as a formula, it looks like this. Take whatever segment 1 is. So I'm going to abbreviate this. Take whatever. I don't care which one you call it. Either the left side or the right side, it doesn't matter. Take whatever segment 1 is and put it over what the altitude is. In this case, the altitude would be x, right? We don't know the altitude. And that will be equal to whatever the altitude is. Well, we just said the altitude was x over whatever segment 2 is. Okay, they're two segments. That's all we're saying. Now, if we were going to try to solve this, we would cross multiply, right? So x times x would become x squared is equal to segment 1 times segment 2. You see what I did there? I don't know what segment 1 and segment 2 are yet. We didn't have numbers for them.
Just do square root.
Now I do the square root of both sides, and look what it's telling me to do. Take the product of the two numbers and then take the square root of them. That's all this formula says, that if you want to know the altitude, you have to know the two segments there. To know the altitude, all you need to do is know the two segments. So we have this formula, and the formula just looks like this. Segment, why do I keep writing G? Segment over the altitude is equal to the altitude over the segment. And it's just segment 1 and segment 2. That's my formula. Segment over altitude is equal to altitude over segment. So one is like the flipped over version of the other, and one of them is segment 1 and one of them is segment 2. And we're actually going to use some numbers for these in a minute. We're actually going to play around with the numbers. Yes, sir?
Why would you subtract segments?
Subtract them?
Yeah, not where I did.
Oh, I'm sorry. That's just a little dot. I'm sorry. It's not. It's a little dot, like a multiplication. I don't like putting X's in because it makes people. I really should have used like parentheses. But sometimes when we're dealing with like words instead of numbers, it's a little confusing. So yeah, just segment 1 times segment 2. Yep.
So you find the geometry for segment 1 and segment 2.
Right. Meaning, so if I want to know how tall that altitude is, take segment 1, multiply it times segment 2, and then take the square root of that number. Remember what we did on the earlier side? Take those two numbers, multiply them together, and take the square root. That's how you find the altitude. Okay? So we take the geometric mean of the two segments. But I just like to remember, for me, instead of remembering that, I just remember the formula. Segment 1 over altitude is equal to altitude over segment 2. So whatever I do, I just plug in those numbers and I cross multiply. That's what I do every single time. All right. Here is our next one, and this is the one that people forget. It says, in a right triangle, the altitude from the right triangle to the hypotenuse divides the hypotenuse into two segments. We already said that. It's saying the altitude, I'm going to draw the exact same thing I did before. The altitude comes down, so let's say that it comes down, and it divides it into segment 1 and segment 2, right? So that's all it does, is it divides into segment. That's all that first little paragraph says. The exact same thing that we saw on the same slide. No different. But the second little paragraph says, the length of each leg. Now remember, we're talking about this big right triangle. We're always talking about the big one here. X and Y are the legs of the big triangle. Because you might be like, wait, which triangle, which legs? We're always talking about the big triangle. So in this case, the legs are the ones that are touching the right angle. Remember, it's X and Y are the ones that are touching the right angles. The length of each leg of the right triangle is the geometric mean of the length of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Check this out. You're going to hear me say this word so often that I have abbreviated this that you're going to get sick of it. So check it out. It is the segment of the hypotenuse that is adjacent to the leg. So I always say, instead of saying all that, I always call it the SOHAL. So I'm going to explain what that is in a minute. But when you hear me say SOHAL, what I mean is the segment of the hypotenuse that is adjacent to the leg.
So like segment 1 would be adjacent to X and segment 2 would be
I
adjacent
love you. Look, here's what he said. He said segment 1 is the segment that is adjacent to this leg. And he said segment 2 is the segment that is adjacent to this leg. Remember, adjacent just means like they're next door neighbors. And I look at segment 2 and I go, which leg is its next door neighbor? For segment 2, it's Y. For segment 1, it's X. Now here's the formula.
Wait, but how can like that them being adjacent? What can that help you with?
Let me show you. It says that if you take the hypotenuse over the leg. Now you might be like, which leg? Well, whichever leg you're trying to find. So let's pretend for a moment that we are trying to find X. Okay, let's pretend we're trying to find X. Well then, the hypotenuse is C, right? Like I'm just looking there and it says that the hypotenuse is C. I don't have numbers for it yet. We're going to use numbers, I promise you, coming right up. So if it gets confusing with the letters, don't worry, we're about to have numbers. The hypotenuse, its length is C. Do we agree? The hypotenuse over a leg. And you said, let's find X first. We can't find both legs at the same time. It's like putting your pants on. You have to do it one leg at a time. If you can put both legs in your pants at the same time without like sitting down, then you are impressive. So what we are going to do, you're putting your pants on one leg at a time. We're going to start with one leg and we chose X. The hypotenuse over a leg is equal to the leg, the exact same leg. It has to be the exact same leg. We're not going to switch to a different leg. The exact same leg over the SOHAL. Now remember, Gio, what did you just say? If it's X that I'm looking for, what is the SOHAL for X? Segment 1, or in this case, they labeled it A. You see how they labeled it A down there? But that's segment 1. Segment 1 is right next to X. Now, let's play the same game. What if I were looking for Y? I take the hypotenuse, which is C, over the other leg, which is Y.
Wait, but I thought it would be C over A is equal to A over...
Okay, the hypotenuse is C, right?
Sorry, I thought it'd be A over X is equal to X over A.
Okay, check it out. The hypotenuse, right?
Yeah.
Which letter represents the hypotenuse?
Yeah, but I thought you were... Oh.
But look at the formula. Hypotenuse over leg is equal to leg over SOHAL.
Oh, I thought you were just looking at the left triangle.
Okay, so we're looking at the big triangle. Hypotenuse is C. The leg that we just decided, now we chose this, that's the leg that we chose, was X. So we're going to use that same leg again over the SOHAL. And the SOHAL for X, meaning the one that's right next to X, is A. But now we're going to play that same game for the other leg. Well, what if I wanted to know the other leg? Okay, well then the hypotenuse isn't going to change. It's just C. The hypotenuse of the big triangle is C. However, there are two legs. So in this case, we've got the hypotenuse over, this is the other leg, is equal to the other leg over the SOHAL. Now, which is what? Is B in this case. Because when I look at the leg Y, which is on the right, its next door neighbor segment is B. It's the one that's right next to it. The segment of the hypotenuse. A segment of a hypotenuse, just even if you forget what that is, look at the words. Segment of hypotenuse. A segment is just a piece. It's a piece of the hypotenuse that is adjacent, it's the next door neighbor, to the leg. The only thing that gets tough here is sometimes people forget and they try to use both legs. In this case, notice that these were the same. Notice that these were the same. Whatever leg you're trying to find. So, two formulas. What was the first formula we had? Okay, so we've got segment, this was the first one, segment 1 over the altitude was equal to
Altitude over segment 2.
over altitude over segment 2. Tell me a pattern about all three formulas. Something that's the same about all three formulas.
Like you can always cross multiply?
Yeah, but that happens with any two fractions that are equal to each other. But I thought you were going to say it. Well, the ones on the left, like, you know, we've got, it's a little bit different there. What's the same, like, pattern every time? Susie?
The first one on the bottom is the same as the second one.
Whatever you have in the bottom left is always the exact same as in the upper right. So just remember that. If you put something in the lower left, then it must go in the upper right as well. Notice x and x, lower left, upper right. Y and y, lower left, upper right. Altitude and altitude, lower left, upper right. Now we're going to play with some numbers, and now we're going to do this a little bit slower because this is where we actually have to do stuff with the numbers. Okay, these are two different scenarios, and we're going to start filling this in. It says if JR equals 16. So here we go. We've identified this piece as 16JR. This piece is 16. If you are not labeling your pictures on this, it is going to be so difficult for you. And EJ is 9. Find HJ. Okay, so first thing they want us to find is HJ right here. What is HJ? Like, what would we call HJ? It's the what? So check it out. What they gave us is 2 segments, and we need to find the altitude. So in this case, we're trying to find x. Talk to me about what I should do. What is that formula that we just got?
Segment 1 over altitude.
No.
Wait.
You do the hypotenuse over.
No,
because you can't do that to
Okay, so let's try both scenarios first.
Oh, never mind. Yeah.
Okay. Yeah.
So we're looking for HJ. Now, do we know what segment 1 is?
No. Yes.
Yes.
Do we know what segment 2 is?
Yeah.
And we're trying to figure out the altitude, so we know 2 out of the 3 things. That's great. That is fantastic. So watch me plug in the numbers. Segment 1. Now, again, I don't care which one you call segment 1 and segment 2, but I'm just going to go left to right. So I'm going to go 9 over x is equal to x over what? 16. Now what am I going to do?
Multiply, yeah. X squared.
Is equal to 9 times 16. Now you can do this. Remember, all you're doing is taking the geometric mean of these. Remember, that's what that means. So you have 2 ways of doing this. If you can do it just mathematically if you want. You can sit there and do 9 times 16. Or we know that this means the same as this. So what is my other option I could do?
You just square them and then multiply? Like,
Oh, take the square root of them, you mean?
yeah. So you get like 3 and 4.
3 and 4.
Then you multiply that and get 12.
So we get this is 12. So now we know that x, or this one right here, I'm just going to take that out because I'll probably use another x here in a minute. I know that this one here is 12.
Right.
HJ is 12. Okay. Now they want me to find RE. RE is this line right there. How in the world could I ever possibly find that? I don't have a formula that told me how to do that.
Addition.
Oh, you mean I could just add those 2 things together? 9 and 16. What is 9 and 16?
25.
That's 25. So this is 25. Now we need to find RH. Notice RH is a leg, right? It's a leg. So guess which one of the 2 formulas I'm probably going to be using?
The second one.
The second one that actually talked about legs. Okay, so I am out of colors here, so I'm just going to use, let's do highlighted. I know, right? It's exciting. Okay, let's find RH. So I'm just going to call this X for a moment because I'm going to go, this is my new X. So I need a leg. Talk to me about a formula for leg. Gio.
Like you would do the hypotenuse, which is 25.
Okay, let's do formula first and then plug in. Here's why. Because if you don't know the formula, you can't start. So we got to keep saying it over and over again until you're so annoyed with me saying it. Hypotenuse over
Leg.
is equal to
Like,
over
So.
Sohal. Sohal. Remember, that just means the segment of the hypotenuse that is adjacent to the leg. How long is the hypotenuse?
25.
Now, what am I going to put down for leg? X is equal to the leg. What am I going to put down for X? Okay. And what is the Sohal for X?
16.
16. It's its next door neighbor right down here. That is the segment that is of the hypotenuse that is adjacent to that leg. So I'm going to do 16. Notice that both 16 and 25 are fantastic numbers. I'm in love with those numbers. I am so grateful that those are not different numbers. Oh, let me do this actually the proper way here. 25. I know, I'm skipping ahead in my brain. So x is equal to the square root of 25 times 16. Now again, you are welcome to multiply 25 times 16 and then try to find the square root of that. But some of us have realized, heck no, I don't want to do that. What am I going to do instead?
Find the square root of both of them.
Find the square root of 25, find the square root of 16, multiply them together. The square root of 25 is?
5.
And the square root of 16? So this answer is?
20. 20.
Going a little fast.
Okay, I'll slow down. You see what I mean? This could be very easy to get lost in if you didn't know the terminology. And that's why. It's not hard math. It's just like, what the heck is Sohal? Could you imagine not being here today and going like, I come back and I'm saying Sohal, 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 and you're like, what is that word you are saying?
I think it's a song.
So,
Imagine like
So
Soho.
also,
okay, check it out. Remember that this large green triangle we have there is a right triangle. And I now know two sides of this right triangle. What could I do if I wanted to? I know two sides of a right triangle. In theory, what could I do? Before today,
Pythagoras.
I could use Pythagoras. Let's say I was stuck at this point and I had no idea how to find that last leg. Pythagorean theorem will work. X squared plus 20 squared will equal 25 squared. But I'm not going to do that today because I want to use this new skill. Because the last one we want to find is HE. Somebody talk to me about HE. How are we going to find HE? Yes, sir. Yep.
Do the same thing that you just did, the hypotenuse over leg over Soho.
Good. I'm going to call this X now. I'm just changing it to a new X because I want that one to now be X. So we've got hypotenuse over leg is equal to leg over Sohal. And we chose this one because we're looking for a leg. So I need a formula that talks about legs. So here we go.
You do 25 over x is equal to x over 9.
Okay, so we're going to cross multiply, and we get x squared is equal to 25 times 9. We're going to do x is equal to the square root of 25 times 9. But you know me, I am lazy. I'm not doing 25 times 9, so what am I going to do?
You're
Yeah,
gonna
you
do
square them.
square, like do
And you
individual.
get
Yep.
3.
Now, don't get me wrong. Sometimes that may not work out better for you. Sometimes you might have to multiply them together. But if it's easy like this, why not just take it? Take it and run with it. This is 15. Notice that all we did was find every little part of there. We're going to have another one that we're going to do after this that requires equally as much work. Now, I'm going to tell you right now, this problem, this exact problem, if you were to dedicate most of your time to something for this quiz, this is where people are going to stumble. If you feel like you could do this slide over and over again, I think that this is the hardest part of the quiz. So if you have followed me along and you're like, that's not hard at all, then great. Then I go, that's fantastic. But I do encourage you to at least make sure that you are practicing, if nothing else, this slide, because this slide gives people troubles. All right, I'm going to do the same thing now. But what I'm going to do now is do a little clearing off of some information here. I'm going to erase some of the things on my triangle just so I have some area to work in so everything doesn't get kind of confusing here. So I'm going to erase them because B is a whole new scenario. A whole new scenario that requires whole new numbers here. It's like, hey, plug in these numbers now. Anybody want to give a shot and take it as far as they can on B? No judgment. If you can't make it all the way, if you can, fantastic. Geo, hook me up.
Alright, so
Let's label first. How about that? I'll label for you. How about that? And then JR is 4. And JH is, ooh, interesting. JH is 2. Find EJ, RE, RH, and HE.
oh, so we don't know both segments.
Yes, but think about what you have. What pieces do you have? Tell me, name the pieces you
So
have.
we have the altitude and one of the segments.
Good, so think about it. You have the altitude and one of the segments. What would be a great formula to try right now? The first one or the second one?
Mr. Hyder, would you send Tyler Brigas to student services for a minute?
He's on his way.
The first
Thank
one.
you.
The second one.
I think the first one as well too, because the first formula says what? Segment 1 over altitude is equal to altitude over segment 2. Now notice here, we know 2 of those 3 things. That's fantastic. When you know 2 out of 3, you are in a great place. Talk to me.
Alright, so I'm going to do 4 as a segment 1.
4 is segment 1.
So 4 over 2 is equal to 2 over s.
Beautiful. What should I do now?
Cross multiply.
Cross multiply, and I get 4x is equal to 4. Is there any square rooting involved here?
No, x is equal to 1.
No. X is just equal to 1. So this part right here that we just figured out, that's 1. Guess what? Now that you told me 1, you just instantly got another piece of information. You know what RE is now. Exactly. What is RE?
5.
This is 5. It's 4 plus 1. So check it out. RE is 5. EJ is 1. All we're left with is the legs now.
So then that's when you use the. Oh, you still.
The second formula is the one that talks about legs.
Yeah. So then you do 5. Well, I'm gonna do RH.
Let me just rewrite the formula again because I want to be so obnoxious that you hate me for saying it. Hypotenuse over leg is equal to leg over Sohal.
Yeah. So then you do the hypotenuse. Which is
Okay.
5.
5 over. Wait, which leg are we doing? I'm sorry.
I was doing RH.
RH. Just so he can follow along, he decided to do this first. There's no requirement that he did that one or the other one first. He chose that, so we're all just going along with it. 5 over
X.
x is equal to
4.
x over
Oh, X over 4.
4. It's Sohal is right there. It's next door neighbor. Okay, talk to me.
So then you cross multiply and get X squared is equal to 20.
X squared is equal to 20. Okay.
And then you do the square root and get X is equal to the square root of 20.